This is Mass Timber Today, and I'm Ann Koven. This podcast explores the opportunities and challenges of mass timber with experts in the design, building, and forestry sectors to shed light on the question, what is the future of mass timber construction? In this episode, I'm speaking with Alan Organschi. Alan is a design principal and partner at Gray Organschi Architecture in New Haven, Connecticut, that is recognized internationally for its integration of design, construction, and environmental research. He is also the director of the Innovation Lab at Bauhaus Erde. Today, we discuss his current work at Bauhaus Erde, as well as his work at Gray Organschi Architecture. Alan informs us about how we need to work to design buildings for a circular economy of mass timber that is separate from an extractive industry. We also delve into his work that exposes him to communities holding essential knowledge about the forest resources they live with and their role in the use of these materials. Additionally, he touches on carbon storage in mass timber buildings and ways we can improve the cost effectiveness of mass timber construction. Alan, welcome to the Mass Timber Today podcast. You're well known in the mass timber industry for your work at your firm, Gray Organschi Architecture, as well as your current involvement with Bauhaus Erde in Germany, and your previous teaching with the Yale School of Architecture. So why don't you tell our listeners how you became interested in mass timber and how it became a part of your career?
That's a potentially long question to answer for me, because sometimes it felt glacial, the change, and sometimes it felt like a rapid fire. But I started out having studied furniture design and worked as a carpenter and a cabinet maker sort of through high school and into college. I was majoring in history of all things, but studied furniture design and focused on wood and just became familiar with it and worked in it in construction industry after college, and then suffered middle-class guilt and went to architecture school to get a professional degree because I didn't see myself being a carpenter for the rest of my life, although it's stuck with me for a long time, so I guess I didn't completely escape that fate. And our architecture practice was really a design-build practice because we had a shop and we were fabricating furniture and components, and then we got into designing houses for clients. And my partner, my wife, Lisa Gray, is a consummate professional. And I was always kind of on the edge, wanting to be a builder as well as a designer. And together, we really started to develop this design-build format and fabrication facility and hiring people and getting larger and larger projects. And our first mass timber explorations were really engineered wood frame, timber frames, glue lam frames, bolt laminated frames with structurally insulated panel enclosure systems. So we were really interested in the articulation of wood and different components in the building. I think the real breakthrough in what I would call like our entry level into mass timber was in the mid-90s. We actually designed some construction access bridges just using glue lam panels. And it was the cheapest thing we could find. And it was a sort of curved wood road. And we made a curved glue lam and we laid it on its side. And that was it. That was mass timber for Gray Organschi Architecture. And then the other breakthrough was more related to research at Yale, which I was doing with some colleagues. We got a grant from the Heinz Fund for Advanced Research Sustainability. And we were looking at kind of what would happen to American housing after the bubble burst, given that, the subprime mortgage fiasco was so much a present part of how we developed housing in the US, suburban single-family houses. And those were no longer viable investment instruments. So we started looking at idea of urban density, using these new mass timber systems like cross-laminated timber, which was really just coming out in 2000, the early 2000s in Austria, and how we might apply that to dense urban building. And that slowly led us into this idea of the timber city, that you could build a city out of wood using these new components that would compete with the mature classes of steel and concrete, and that there were explicit and measurable benefits environmentally and climatically to that transition. And here we are today working in those very topics.
What is it about mass timber that you find so compelling? What makes you so passionate about it?
Well, it's as I mentioned, because I started with wood, it seems like a sort of natural kind of scalar shift up into using big wood components. I mean, like all architects and builders, it's a really cool material. It's really workable. It's very beautiful. it's impressive and in its novelty and in its potential scale, which I think it shocks a sort of contemporary eye. When you see big, heavy timber components that are really robust and yet beautifully finished. I mean, even an industrial finished glulam or panel of CLT has a kind of character to it. And just the size, again, is amazing. But then if you start thinking about kind of ecological benefits, it potentially uses smaller and smaller pieces of wood, which means potentially smaller and smaller pieces, trees rather. And you use these things, and using these techniques of lamination and ganging, whether with nails or bolts or adhesives, you can create enormous, massive structural components that have competitive capacities, again, with these other classes of materials that marked the kind of building trajectory of the 20th century. And then finally, when you think about the size of these things and the sheer volume of wood that's going into them, and that wood's capacity to store carbon, suddenly you have this transfer mechanism which can take wood coming from sustainably managed forests. That's critical. We'll talk more about that, I think. Move it into this enormous repository of material. Cities are largest stockpiles of human-made material. And in doing so, store that carbon that was photosynthetically generated in the city, while forests then, ideally, are able to regrow. So it's a virtuous circle. And so we combine this beautiful, cool material, which is really easy to work and manipulate, that could create whole economic opportunity across cities and rural regions, that stores carbon, that has lower production emissions, and you start seeing the potential, and I stress potential, of this highly synergistic and symbiotic relationship between two landscapes, the city and the forest, that have historically been in an antagonistic and even predatory relationship. The city consumed the forest. And so that's the trick now for all of us. We have to try to manage that potential synergy.
Thank you, Alan. That's you put it so well, how the artistic creative side of your profession of architecture is so attracted to wood, and how the mass timber possibilities naturally take your profession. It inspires curiosity about how can we use wood? Should we be using wood? Why would we use it? And what the benefits of mass timber would be.
Yeah.
Thank you. What are you doing now in the world of mass timber? What mass timber projects are you currently leading or involved with?
We have a lot of irons in the fire, to use a perhaps inappropriate metaphor. So at Yale, where I've actually taken a leave of absence in order to direct the innovation labs at Bauhaus Erde that you mentioned, I'll talk about that in a minute. We finished my tenure, at least temporarily, with a project for a coastal research station on an island off the coast of Connecticut, where Yale University is. And these are beautiful little islands that have really interesting marine ecosystems. And the Peabody Museum of Natural History commissioned my lab, which is essentially a design build lab, to build a coastal research station. And we chose to do it out of entirely regenerative materials and methods. And one of those was to take material that had been used to construct a test structure for the fire safety lab tests at the Alcohol, Tobacco, and Firearms Lab in Beltsville, Maryland, which was a 2-story structure that they tried to burn down, built a CLT, tried to burn it down and couldn't. We salvaged that material with the help of Bill Tobin at Lend-Lease and with Smart Lam, and we moved that material to New Haven, and we built an affordable house for 3 homeless men. And we also took some of those panels, restored them, moved them to the island, and built large components of the coastal research station for scientists. So that was going on. And then at the same time, we're working on multi-unit housing with Binderholz in Austria and with Smart Lam in the US to create 3 projects. The first project is, I believe, the first affordable housing built entirely with mass timber and primarily CLT in the country. It's a 0%, in some cases, market rate affordable housing. So it's really deeply affordable. And we're working with a really wonderful client in that. We're doing market rate housing in Chappaqua, New York, a commuter suburb of the city, and also doing a wonderful overbuild on a 4-story unreinforced masonry structure, a building from the turn of the 20th century, 19th to 20th century, and putting a 2-story addition on it and turning it into housing. What's really important about that is there are so many of these historic buildings that exist in cities like New Haven, small post-industrial cities, and they're land poor, but rich in this building stock. And we've used mass timber essentially to not only increase the height and number of units in the building. We're using an existing building, which is a key to the circular economy. We're adding bio-based materials to that brick structure to store some carbon. And the stiffness and the lightness of mass timber is what actually creates the reinforcing system for this non-reinforced masonry building. So we couldn't do it with any other system. And so what we've done is essentially placed, I'm describing this as if it's simple to airlift it in, but in fact, we sent a shaft down 4 stories into the basement, locked that circulation core into foundations. And then we built this sort of tree of 2 stories of mass timber on top of that. And that locked the entire building together and enabled it to be able to carry that load. And we're designing a bridge along the Hudson River for a 9-mile lineal park that crosses over the Metro-North Railway. And in Germany, we're developing supply chain studies about forests in Brandenburg, which is a state around Berlin, and studying how we can restore forests by using wood rather than destroying forests to use wood. And then finally, a project in Bhutan, of all places, where we're working with the Kingdom of Bhutan to turn their enormous forest cover into a regenerative system to supply their rapidly growing cities with urban building stock built of engineered wood. So it's jumping around all scales. My hair is on fire. It's really exciting. The people I'm getting to work with, like you, are amazing, knowledgeable, and they care a lot about the environment, which is the most important piece of it. So I don't know how to stop, but I'll stop there.
Thank you. I think that's the most interesting project list you've ever heard for mass timber. You touched on everything from fire to structural innovation, design,
it's diverse at least,
and international development. You're covering everything, and affordable housing, a topic I hope we'll return to, because certainly in Canada and the U.S., this is a very, very big issue, and we, as you, are hoping there's a place for mass timber building in that sector. There's currently a lot of discussion about what makes mass timber a more environmentally responsible and sustainable building material. What's your take on this question?
Well, I think that the sort of inherent properties of wood make it potentially sustainable, right? I mean, look, global capital can destroy landscapes, whether it's made of wood or it's a mine or, we place enormous demand on the physical resources that are available, material resources that are available to us as a highly technologized species. We have historically really destroyed remote landscapes without any feedback mechanism at all, because we're digging holes in places far away from where we're building and transporting using really sophisticated transport systems to process the material and move it to our site, and then we build with it. And I think what's happened is that as architects and builders and engineers, we've become a little bit disembodied from this removal or extraction of material and its potential impacts. And that's a really important part of this whole equation, that without those feedback loops, without understanding our overuse and potentially abuse of landscapes and materials and ecosystems, we run the danger of destroying that resource. And forests are not immune to that. They're actually really vulnerable to it. So I think those properties of wood that I talk about that are inherently sustainable are, it's a biological material that grows. It uses sunlight and water to create material. It's kind of the perfect low energy density manufacturing system, right? If you compare that to actually smelting steel or sintering clinker for cement, it's easy. We just have a big landscape covered in leafy green stuff, and the sun pulls carbon dioxide out of the air and turns it into structural material. It's amazing. But with that very simple and technically deterministic kind of description of forests, we also have this rich ecosystem that exists within it, and this enormous capacity to store carbon in the soil as well as in the woody and leafy matter. So we have to protect that system. And we have to take fullest advantage of it and turn it into a kind of force multiplier by also doing everything we can to reduce the transport costs of this material, the harvesting impacts to the land and soils. We have to reduce the production emissions that go and energy consumption that goes along with the processing of that wood into structural products. And we have to build it in a way that is durable to make buildings as long-lasting as possible, because that's the best and most effective way to reduce energy consumption and emissions. And then we have to make buildings demountable, so we design them for disassembly and reuse. And that reuse piece is really important. We have to develop scenarios to reuse that wood. Otherwise, all that benefit goes away when the building is reached at the end of its service life. So for me, this is a really complex discussion that is a transdisciplinary, transsectoral system, which if we don't understand it as designers and understand how our choices of material and the amounts and how we use them and detail the assemblies, we don't really understand it systemically, we run the risk of just creating one more extractive industry, like the fossil fuel industry, which will leave destruction in its wake. And so I say always, and this is to quote a really good friend of mine, Keel Mo, we could really screw this up, and we have to be very careful that if we're going to claim all the benefits of wood, that we have to also understand its vulnerabilities, the vulnerabilities of forests. And having said all of that, honestly, there are a lot of forests that would benefit from the kinds of restoration that sustainable demand could produce. And it would incentivize rural job growth and enterprise creation. It would also, we're seeing this in New Haven, where it's incentivizing urban construction jobs, new construction jobs. So again, it's economically and ecologically and atmospherically sustainable if all of the pieces are working right. And that's actually what our work at Bauhaus Earth is about. It's trying to actually build a systemic understanding of how to use materials, because we're going to have to build cities for 2.5 billion people in the next 30 years. And if we do it wrong, or do it as we're doing it now, it is actually a dead end, a planetary dead end, or at least a species dead end. And if we do it right, it actually could be a key to restoring the climate. And that is an amazing balancing act that we have to find.
Well, Alan, you're certainly singing from the same songbook as foresters.
Yeah, well, I work with foresters.
You work with foresters.
A lot.
And I'm a forester.
Yeah.
And certainly the forestry profession is very excited about the idea that the work of architects and engineers in mass timber and other sustainable wood construction can bring more investment into forests by way of government funding, by way of private investment.
Yes.
And that's something that's sorely needed around the world. And of course, we can get into more details about how this will benefit sustainability. But there's just a very interesting meeting of minds on how this could be beneficial both to the urban built environment and forest regeneration.
Absolutely.
One of the reasons that so many architects and engineers are excited about mass timber is because of its ability to lock up carbon and reduce embodied carbon. So can you talk more about how mass timber and forests are a key part of the solution to carbon emissions and climate change? And again, with respect, I guess, to your Bauhaus project, this is very, very germane.
Yeah. Well, this is something that we've been working on now for 15 years. And it started as a flicker of an idea that we saw that essentially we could throw all the technologies at building that we wanted to try to reduce mechanical systems or make them more efficient, and against the sort of changing baseline of a warming climate, and not to mention just general technological obsolescence. We're actually working against, we're on a treadmill, and we weren't moving forward. And we see that with the sort of technological focus of past sustainability efforts actually haven't proved to be that beneficial. What they've done is they've created a lot more material demand with much more material intensivity, creating increased cost, which we're going to hopefully talk about a little more. but not really reducing our footprint, either as consumers of energy or as emitters of carbon. And so I think that this just simple capacity of wood, 50% roughly carbon in its chemical makeup, is something that we really have to look and study closely. And I think that as I mentioned earlier, I think we have to also understand the entire system, because if we don't make sure that we protect forests and incentivize their expansion, afforestation, et cetera, we don't get the full climate benefit out of it. Just as if we allow, I believe, these degraded working forests in places like where I grew up, New England, formerly deforested landscapes, which are now second, third growth forests, of rather decent but not wonderful quality. If we're just allowing those forests to maintain as sort of slightly degraded, disturbed lands, we actually don't get the full ecosystemic benefit of forests either. So we have a weakening carbon sink. And so now we want forests to be really healthy, because upstream environmental health creates potentially downstream access and health for the public. And that's really exciting. So we first looked at, how much carbon is in a building? How much does a building weigh? How much carbon occupies that footprint of the building? If it's, a suburban house on a 2-acre lot, or a 7-story mass timber building in a city on a narrow, small lot. And obviously, the building with a small footprint and shared infrastructures and enclosures performs incredibly in terms of carbon storage capacity. And so then we started saying, okay, so what happens if we build out a city district? How much carbon can we store? And we found pretty quickly, and it's basically arithmetic, that the more buildings you build out of this material, that you build durably at a sustainable rate below replacement rate in forests, you can actually use regional forests to supply most of the vision plans that cities about the size of New Haven have, right, for their building. And we took it a step further. What happens if we look at all of New England and we start thinking about building in the demand centers along the eastern seaboard of New England? And then we looked with climate scientists out of the Potsdam Institute for Climate Impact Research, and a carbon assessor, and a forester, and an industrial ecologist from Yale, and an engineer from Bensonwood, and a forester from the Forest School at Yale. We essentially modeled what would happen if we built out that 30-year building boom for 2.5 billion people entirely out of timber. What would happen to forests? Is there the capacity? And how much carbon could we store? And we pretty quickly saw that there's no other means by which we could store that amount of carbon and potentially incentivize forest restoration. And so for me, it's a trend-scalar thing. The idea that when I'm sitting at a table right now, which is made of an old piece of myrtle, which we recovered from an old factory, and that it's made half of carbon, and then it's actually quite sturdy, and I could make a building out of that and store carbon, is fascinating. And then, of course, you start thinking about carbon credit programs for forests. And then you think, could we actually credit the carbon that's in buildings? And would that incentivize affordability in the affordable housing market, or promote dense development in cities, which are struggling to have, populations that really can support other kinds of services like mass transit, et cetera? And so for me, this is like a cornucopia of possibility that's based in this simple observation that wood stores carbon. And that's the thing that we're pursuing at all levels. And, our paper, Buildings as a Global Carbon Sink, which was published 3 years ago in Nature Sustainability, which was a weird collaboration among scientists and designers, became a model for how we're trying to conduct our work at Gray Organschi Architecture, what I'm trying to work with my colleagues at Yale, and what Bauhaus Erde is about, which is we have to dissolve the relationship between research and assessment and analysis, and design, experimentation, and implementation. And once those things start to move together, and people like you, forester, are talking to people like me, architect builder, we have a chance. But it has to be you telling me when I've gone too far, and me telling you, this is how I can use this piece of wood that you've just removed from the forest for some other reason, maybe to reduce fire risk, or improve soil health, or improve the watershed, or reduce invasive species, or enhance biodiversity. I mean, you as a forester practicing ecological silviculture have all these other motives for working in the forest. Could we, instead of demanding what the forest give us, ask the forest what it can give us? And that shift, which is sort of a paradigm shift for investors, right, and industrialists, is, I think, a important key.
I couldn't agree more, Alan. And certainly it also, when we're looking at some of the important social and economic impacts, we're looking at the ability of regional economies to benefit from urbanization.
Absolutely.
And as we know, the ex-urban area has been, well, that's a whole other discussion. But I think when we talk about the possibility of value-added mass timber production beginning with the forest and small communities that produce the wood, that harvest the wood, I think there are many kinds of factors associated with good jobs, associated with regional stability, associated with more equitable wealth distribution. There are all kinds of reasons, I think, why our discussions between forestry and architecture, of course, have a much broader an influence.
Yeah, of course. I couldn't agree more. What I see, and I know in your work, the idea that an indigenous community that has, through sort of modern governance programs, been stripped of its ability to practice the kinds of skill sets that were part of being a forest community, right? How to see what trees are growing, what kinds of silvipastoral agriculture could be practiced, whatever it might be, what kind of products can come out of it. We've sort of disabled societies that are very familiar with forests because we've tried to apply a kind of universal approach to everything we do. And we've lost this knowledge base, which is really deep and which would actually enfranchise those very communities that have been stripped of those capacities. And I don't mean to say that in a sort of paternalistic way at all. I mean, I go into these places like Bhutan, and I go up into these forests, and I work with people who are living in the forest and working from it, and they have deep knowledge that I would say most architects don't. And you do, you're a forester, but this is traditional forms of knowledge that I think are irreplaceable and at risk of being lost. So our work at Bauhaus Earth is actually trying to engage both the kind of socioeconomic enfranchisement of all communities, right? Whether it's an urban community trying to have good, healthy housing, of high quality, that's stable and secure, or a community working in the forest that could benefit from that demand side. And I find it, even the way I'm talking to you, I'm finding there's a way like it's this convoluted, intertwined system of discussion of different forces that I'm having trouble organizing now because it's like tentacles. They go everywhere. And yet I think we have the disciplinary knowledge, if we can work together, to sort that and to optimize it as a dynamic system. And we just don't do it globally. And we're getting better at it in North America and Europe. But that's not where population growth is happening. And that's not where social inequity is the deepest, although we have plenty of it here. So I think these discussions have to happen. They have to happen in architecture schools, and they have to happen in forestry schools, and they have to happen in investment communities and policymakers and material scientists and. Because until those themes are kind of embedded in the way we think about these things, we're just going to be consuming products and creating linear waste flows. And I really want to avoid that if possible.
Alan, let's talk more about biogenic carbon, locking up carbon in mass timber. Biogenic carbon seems to be a hot topic and in some circles, highly contested. What's your take on its place in the argument for mass timber?
Well, I guess I'm kind of beating a drum pretty hard here. And I would say that with all the caveats that I've offered already, I think it plays a fundamental role in an essential role in climate restoration, biodiversity enhancement and protections, and social equity. So I think that these are all, as I say, intertwined. But it can't be an alibi to cut down forests, right? I mean, that's a problem. A simplistic reading of this is what scares environmentalists who are saying no more cutting, folks. They're doing it because they're using the models of how we've exploited forests in the past, and we have to show and demonstrate new models of ecological silviculture that produce new kinds of wood products, not the old stock that we've been relying on, the sort of monocultural forests that we want to grow to feed the maw of building consumption, but rather a much more nuanced, flexible, and responsive kinds of innovations, in design, in manufacturing. And I think that's really possible. I think it's like a smart manufacturing system. But yes, we have to be clear. Like, if we don't acknowledge that there are risks to forests that come from all forms of all factors, all forces at work, whether it's land conversion for agriculture and beef ranching or mining and mineral extraction or suburbanization or wildfire and climate change itself, all of these forces are creating land conversions at an alarming rate and weakening the global carbon sink, our forests. But let's look at the alternative. If you think about building all of that 2.3 billion people's worth of building out of mineral-based, fossil hydrocarbon-fueled material classes, we have another problem. And that's a system analysis that's been missing in the discussion of people who are worried about using forests. If you say we must protect forests, you have to also acknowledge that you may not be protecting other landscapes or even forests when we sort of dig them up to get the karst limestone out to produce concrete. And I think that sort of system boundary expansion in our basic analysis of what we have to do has to be taken into account, because otherwise it's a he says, she says kind of discussion, which we can't have anymore. It's too little time to act. And we have to stop this alarming and accelerating trend towards hothouse earth conditions. And we have to understand all of the ways in which our choices as consumers will create conditions that will ameliorate that or will accelerate it. And that's why it's contested. It's legitimately contested. The problem is we have varying degrees of a systemic analysis that take place, and that's really what we have to work on. And I don't think I have the answers. If you told me in 10 years, you were wrong, actually, and you could show me all of the levers that were pulled and all of the cascade of events that followed from that mechanical action that were negative and deleterious, then I would say, yeah, you're right. But we're not transforming the building sector fast enough to create the kinds of damage that people are worried about. And so we have to take action with the kinds of pilot projects that your organization and institute are promoting and that our colleagues around North America, Canada, US are developing. And we have to see what happens, but we have to legitimately track the impact that's remote as well as the success of the structure in situ. And those two things, again, I'm arguing for the synergy and symbiosis. Without it, to me, I think the concerns and the disagreements about the role of carbon storage in buildings are legitimate and remain legitimate.
Alan, I'd like to step back for a minute. You mentioned before, maybe we could talk a bit about the cost effectiveness of using mass timber.
Yeah.
What do you think, as a designer and builder, needs to be done to make mass timber the most cost effective option?
Well, I think the early adoption problems are many. Well, first of all, everything is more expensive if you don't have economies of scale to generate optimized industrial systems, transport systems, and basically knowledge about how to put these buildings together. So I get a lot of calls from developers who are showing me a building that was designed in cold form steel stud or wood stud, 5 stories. And they say, can you turn this into a mass timber building? We really want to make it out of, no, they don't ever say mass timber. They say, we want to build it out of CLT. And I said, well, CLT has certain applications. There are other structural components and engineered wood systems that could also be applied appropriately within this building. But you start from the ground up because there are certain logics and span capacities and properties and detailing conditions that will allow you to optimize this material or allow you to make your building cost a whole lot simply so you have a wood finish on the inside. And I think that's one of the things we have to address, right? Which is we have to train people what these materials can do, how to apply them in the building assembly, how to optimize things, how to design things that architects have not thought about typically, which is how many picks of a crane will it be required to put this building together? And is it going to cost more to ship on bulk and have to store that material and then move it again to a building site? because this stuff's really heavy. Which direction does the grain go? Don't design a moment frame in wood because wood is not good at making moment connections, et cetera, et cetera, et cetera. Like there's so many things about the knowledge of how we use wood, which is lacking right now. And you see in societies that have been working with wood or have traditions of wood, like Austria, where this Handwerk tradition is really strong. You mentioned that you were living there at one point. And you start to see that the mass timber revolution exploded first as single-family house prefabrication because labor costs were high and they couldn't pay site carpenters a lot of money to spend time there. So they basically built a lot of stuff in factories, moved it, set up houses. And then innovations from people like Andrew Waugh said, well, why don't you use this system to make a multi-story building in cities? And they did that. And now they've refined it. And now these buildings are on par in terms of cost with more conventional buildings. And they certainly take less time. There are lighter materials, which create lighter material handling equipment. There's less noise in the city where these things are being built. And all of these benefits and cost reductions accrue across the development pro forma, not just in the cost of material. And we make the mistake of saying, well, I can get the steel frame for less money than I can get the CLT assembly. And then you say, well, you can't leave steel unfinished. You have to put drywall in and blah, 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 right? So it's not always cheaper. It can be cheaper. And then the holy grail is you get enough really robust and regenerative forest harvests that are supplying really well optimized industrial facilities. And now you have real cost effectiveness. And we just have to build a new typology of building that understands the best way to take advantage of this novel material. And we haven't done that yet. So that's the next charge for all of us to try to identify that.
Thank you, Alan. There are many challenges associated with the mass timber supply chain. You've touched on a few of them and might want to say more about the key friction points. But on the flip side of the challenges coin, from your vantage point, what do you see as the most important opportunities for mass timber design and construction?
I just spent a bunch of time in Barcelona working on a project there. Bauhaus Erde teamed with the Vidaura Labs at the Institute for Advanced Architecture in Catalonia to build a mass timber building in the iconic Mies van der Rohe Barcelona Pavilion. So we did a demonstration of what would happen had Mies van der Rohe in 1929 built this building not out of concrete and steel, but out of wood. And we built a mass timber building and by a wonderful mass timber manufacturer, Silo Nor. And it was published, and you should see it. It's pretty cool, and people really loved it. But, I spent time wandering around Barcelona for a few weeks as we were doing these installations and working with these great colleagues, and Dani Ibanez and Vicente Guayart at the IAC and Vidaura Labs. And I thought, okay, here's a dense city with 8-story buildings, much like Paris and London, parts of New York. And that's the sweet spot for building out of cross-laminate timber and glulam. It's not skyscrapers, although it's really cool and experimental to try these things. And it's definitely proofs of concept of structural capacity. And it helps us address all kinds of concerns about fire and egress and stiffness and seismic resistance and all these kinds of things, right? It's good to make tall building tests, but that's not really where we're going to be building convivial cities. And all you have to do is walk downtown in Manhattan where they're building these needle towers. And these are not convivial, equitable cities. Whereas Barcelona feels more like that to me. And I've been in cities in Asia that were similar to that. And it just so happens that that's that place that these mass timber systems really excel in terms of cost, logistics, interior air quality. I mean, all of these benefits that will make cities more convivial. And so to me, I think that we can't really talk about the benefits of mass timber just generically. I mean, I wouldn't build a suburban house out of mass timber. That would be an utter waste. Nor do I have a real desire to figure out how to build a 40-story tower out of mass timber. That just seems like a misplaced, to me, obviously, not to take away from the great experiments that people are doing. And so for me, the city that exists at that optimum size happens to fit beautifully into this sort of suite of kinds of buildings that mass timber can produce. And that's exciting to me. And then I start thinking about the next stage, which is what is the city's relationship to its hinterland? What does this bioregion that's going to supply it look like? And does it exist? And how can we move that material to places that might not have access? And in those places, maybe we shouldn't be talking about mass timber at all, but other systems and other urban morphologies. But I say all that because right now what we do is we just assume that everything should be built out of reinforced concrete or steel and with curtain walls of glass that are, have huge impacts in terms of carbon footprint. They don't perform that well thermally, and they're not always even that comfortable. And yet it's the reflex of our building sector. And so to me, the real potential in the city building sort of portfolio of mass timber is that it's a disruptor. I don't love that word, but it truly is a change agent that makes us think differently about how we consume materials, as well as being a good material. It also shows something to us about our behaviors and how we need to mend them.
Yes. And in Canada, we're also having the discussion, as I know you are, Alan, about the very ordinary buildings that will be suitable in the future, given good sustainable supply chains from which we'll use mass timber.
Yeah.
And, it could be a mall, it could be a donut store, it could be a gas station. There are some buildings that we simply don't have the time or the imagination at this point to conceive of.
Yeah.
But I think that given, as you say, at the root of all this is a sustainable forest and a sustainable supply chain. And certainly
that's right.
we're probably some distance from that, but your remarks are very encouraging, and certainly we're out of the starting gate.
Yes, I think so.
That's what I'm taking from what you're saying. Alan, as we move towards concluding our interview, I'd like you to tell the listeners what are the 3 articles or websites or books related to mass timber that you recommend and why?
Oh, that's so hard because it's changing so fast. I think there are a lot of collections by architects of note whose work people should really be looking at, because it includes not only the architects having thought of it and worked on it with engineers, but also the builders who are developing an incredible facility, in places like the Pacific Northwest, around the eastern sort of 49th parallel, where we all sort of hover, across Europe. I mean, I really recommend that people go to Austria if you can afford it, the time and the money to get there, and look at Western Austria, this little region, which is filled with the kinds of building types made out of timber, mass timber, that we're just talking about. And so for me, the experience of those buildings is the first hook, because they're exceptional and exciting and novel, and they inspire in ways that I think architecture, for me, hasn't been able to for a while. I think we got a little bit into the margins while I was developing in my own career. And then I'd also encourage people to look at things like Detail Magazine by Birkhäuser, the manuals on timber that they've produced. And those are really great publications. Routledge has some great books that are starting to look at forests and timber. And you just have to skim through them. There's so many. And I want to do a little self-serving pitch, which is that we just published Carbon, a field manual for building designers, which is putatively about all building. But if you really read strongly into it, you understand the benefits of using bio-based materials. And frankly, as you say, the thing that got us out of the gate is mass timber, really. And I encourage you to look at those kinds of publications, which are not explicitly about mass timber, because you should look at pictures of mass timber and great publications like Wood Design Building Magazine, and look at their awards publications, which are amazing, and go see mass timber buildings wherever you can. But also try to understand the science that underlie the value of using mass timber. And that's a really important piece, because if we're just buying a new product, I don't think we've gotten the point. That's why I'm pushing our book that I wrote with Andy Ruff and Matti Kuitunen at Aalto University, because we were really just trying to get to the bottom of the impacts, the sources of carbon flow through the building life cycle, and how we can stanch that flow, and how we can grab that carbon and store it and use it as structural biomass to the benefit of the climate. So I really encourage readers and architects to consider that system, which I've sort of been arguing ad nauseum for the last hour, and I appreciate your patience with it, but I feel like it's really important.
It's tremendously important, Alan. And before we sign off, can you provide a website for our listeners to find out more about what you, Gray Organschi Architecture, and Bauhaus Earth are doing?
Yes, it's grayorganschi.com, www.grayorganschi.com, and that's a really hard name. My wife and partner, Lisa Gray, had the easy name, Gray. My name is Organschi, Organschi. So it's those two names jammed together.com. And in that site, you'll see some of our experiments with wood at different scales, recording studios using bent plywood to shape sound, the multi-unit housing that we're working on currently, bridges, and other kinds of structures. And by the way, there are just so many talented architects and firms at work using these materials. So please look around because you'll find even more astounding things on other people's websites. I'm very proud of our work, don't get me wrong, but there's really beautiful work being done. Bauhaus Earth uses the German website. So it would be www.bauhauserde.org. So it's BAUHAUSERDE.org.
Excellent. Thank you very much, Alan. Appreciate your time and an intensely interesting and educational discussion about mass timber. Thank you.
Always great talking to you, Anne. Thank you for including me in the series. Really appreciate it.
The Mass Timber Today podcast is produced by the Mass Timber Institute at the University of Toronto's John H. Daniels Faculty of Landscape Architecture and Design, and explores the opportunities and challenges of mass timber with experts in the design, building, and forestry sectors to shed light on the question, what is the future of mass timber construction? You can find the show notes and any references mentioned in this podcast on our website at masstimberinstitute.ca, where you can also view our current projects and subscribe to our newsletter. This episode was edited by Derek Welsman and produced by Sean Shukla at the Mass Timber Institute. We'd also like to give a special thanks to Dialogue's Toronto studio for their generous sponsorship of this podcast. If you like this podcast, please rate us on the Apple iTunes ranking site. We'd also love to hear from you with any suggestions for other people you would like us to interview. You can reach us on our website.